Welcome back, mathematicians. Here we are again, trying to figure out the unknowns for a problem. Our learning target today is I can solve for an unknown in a story problem using an equation and a model. Let's go ahead and get started. As we begin, you will need your paper and pencil or your whiteboard and your marker. If you need manipulatives such as cubes or counters, you can also have those ready. Go ahead and pause the video, make sure you have your materials ready, and when you're ready, hit play. All right, guys, let's go ahead and get started. Our first word problem is there are 7 students on the playground. Some more students came out to join them. Now there are 13 students. So how many more students join them? Let's look at this one more time. There are 7 students on the playground. Some more students came out to join them. Now there are 13 students. So how many students came out to join them? Let's go ahead and look at what we know. We know that there are 7 students on the playground. We also know that some more students came to join them. Do we know how many? No, so that's going to be our unknown. I'm going to go ahead and box our unknown. Now it said some more came to join them. So do you think we're going to add or subtract? That's right, we're going to be adding. Since this says some more came, I'm going to put a plus sign in our problem. Now there are 13 students. So if there were 7 students and some more came to join them, now there are 13. On your paper or your board, write an equation that you think would go with this problem. When you're ready, hit play. All right, let's think about what we know. I saw a misconception, so let's go ahead and address that misconception. Someone said 7 plus 13 equals box. Let's think about why that would be a misconception. It said in the problem that there were 7 students. It said some more came, and now there are 13. So if now there are 13, could I have 7 plus 13? Would that tell me how many joined? No, because 13 is our whole. 7 is our part, and this sum is our part. And if this is our whole, and this is a part, and this is a part, I never add my whole to my part to get my other part. I know I wouldn't say 7 plus 13 because it says now there are 13. This would be more than 13 if I added 7 and 13 together. So what would be the correct equation that I would need? Great thinking. Could say that there were 7 students. Some more came to join them. And now there are 13. There were 7, some more came, and now there are 13. I could also think of a subtraction problem that could help me as well. This is a part, and this is my whole. I could say 13 minus 7 equals my missing part, because I can take my whole minus a part to get the other part. Let's look at some models that might help us. On your paper, try to solve this problem with a model. When you're ready, hit play. I saw some great thinking. I saw someone say 7 plus something equals 13. So they drew their 7, they drew a line, And then they use their counting on strategy to help them get to 13. Let's do that together. 7, 8, 9, 10, 11, 12, 13. So how many would I have to add? Let's count. 1, 2, 3, 4, 5, 6. So that would mean that 7 plus 6 equals 13. Great thinking. I also saw someone try to use their number line. For my number line, I could either add 7 plus something, get to 13, or I could do 13 minus 7 equals my box. If I start at 7, I know I want to end at 13, so I'm going to go ahead and box that 13. Now I'm going to count on to see how many hops it takes me. 7. So 1, 2, 3, 4, 5, 6. So how many did it take me? It took me 6. I could also think about subtraction. I could think 13 minus 7. So if I'm at 13, I could go 1, 2, 3, 4, 5, 6, 7. And my answer would be 6. So I would minus 7. 13 minus 7 will get me to 6. A favorite that a lot of people like to use, of course, is our part-part whole or our number bond. I know my whole is 13. I know the part I know is 7. What I need to know is how many are missing. So 7, 8, 9, 10, 11, 12, 13. And my answer would still be 6. Those are some great models, guys. Make sure as we go through our problems that you think about what is asking. What do we need to find out so that we don't have any misconceptions? Because this misconception wouldn't make sense for what we're trying to find. Let's try another one. There are 16 pencils in a box. 9 are yellow. The rest are red. How many pencils are red? On your paper, we're going to try and figure out what equation would make sense. I know that there are 16 pencils. I know that 9 are yellow, and I know the rest are red. Since I don't know what that number is, I'm going to go ahead and box it. So knowing this, if I know there's 16 pencils in all, that number must be my whole. I know that 9 are yellow, so that must be a part. And the rest are red, so that's my other part. What equation could you write to help you find out how many are red? On your paper, write down your equation, and then when you're ready, hit play. Great job, mathematicians. So I saw that if this is my whole, I could say that 16 minus the part I know equals the part that I don't know. These are my yellow and these are my red. I could also say 16 minus the part I don't know equals 9. Or I could use addition. I could think, well, there are 9 that are yellow plus the part I don't know that are red equals 16. I could also say that the part I don't know, which is red, plus the 9 yellow will leave me with 16. All of those equations would work because this is our fact family. We put a box in the place of what we don't know. We know we can add our parts together to get our whole. We know that we can take our whole and minus a part to get the other part. On your paper, what kind of models could you use to help you solve this? When you're ready, hit play. Great thinking, guys. So I saw a lot of good models that people were using. One model I saw was using an addition sentence. They had 9 and they counted on until they got to 16. So let's do that. 9, 10, 11, 12, 13, 14, 15, 16. So how many would they need to get to 16? Let's count. 1, 2, 3, 4, 5, 6, 7. So 9 plus 7 equals our 16. Great thinking. I also saw someone use a subtraction fact. I saw someone take their number line they started at 16, they minused the 9, and they ended at 7. Another strategy that I saw someone using was their part whole or their number bond. So if I had a number bond, my whole always goes here. So I'm going to put my whole in. The part that I know, I'm going to put here. And then I can count on to help me figure that out. I can say 16 minus 9 equals box, or 9 plus box equals 16. So let's try that. 9, 10, 11, 12, 13, 14, 15, 16. And my answer would still be 7. Another way that you could show that is with just counters. So if they drove 16 counters, they had 16, and they knew that 9 were yellow. So they did 1, 2, 3, 4, 5, 6, 7, 8, 9, and they drew their line. And I'm going to go ahead and color those in so we know that those are our 9. Then how many had to be the other color? 1, 2, 3, 4, 5, 6, 7. So that would be my 9 yellow and my 7 red. And I can think 16 minus 9 equals my 7. I could also think my 7 plus my 9 equals my 16. Or I could think 16 minus the 7 would equal 9. All of those would be great models to use. You guys did great this week of trying to solve for unknowns in story problems. Make sure you always label your parts and your wholes in your problem to try and see what would be the best way for you to solve. Sometimes you can use subtraction, sometimes you can use addition. But we must make sure that we know what the problem is asking so that we don't have these misconceptions. Great job today, guys. Continue practicing with trying to solve for unknowns in story problems using an equation and a model. I'll see you next time. Have a great day.